Hello Year 11 and welcome to our fifth and final video here for our topic on interest and depreciation. We haven't spoken about depreciation up until now and we're about to. Straight line depreciation today. There is another type that's called declining balance depreciation. We'll learn about more of that next year. And we talk about depreciation, we're talking about an asset, something like perhaps a car, that decreases in value over time. You put money in the bank, you would expect it will increase in value over time. Okay, it earns interest. But some things, right, because they accumulate wear and tear, or they become less fashionable or something, some things lose value over time. Okay, and that's called depreciation. Straight line depreciation has a lot in common with simple interest, in that the graph shows a straight line. The main difference with depreciation is it will have a negative gradient rather than a positive gradient, right? It goes down. One of the problems with the straight line depreciation method is that this model will eventually predict a negative value of an asset. And that's not really very realistic. Okay? But it's a relatively easy way to calculate depreciation and accurate enough for short periods of time, typically. So, straight line depreciation, here is the formula. S is for salvage value. That's what it's worth now. Okay, what it's worth now. Not how much it's decreased, not what it's worth originally, right? What it's worth now. V, with that subscript 0, right, is my initial value. That's like value at time equals 0, after 0 time has passed. That's what that little 0 is representing. We don't change it or anything, but just a bit of an explanation why it's there. My initial value is represented by V subscript 0. That's a bit like our principal. Minus D is the amount of depreciation per year. That's just a dollar figure. Times the number of periods. Alright, end number of periods. That's been very typical so far. Let's see how we can apply this formula. I've got a motorcycle here. My V0 is 16,000. It depreciates by this much per year. Notice there's not so much as a percentage mentioned here. That's just straightforward. D is 2,400. N equals 3 years. And so we're ready to go. Right, I want to find the value of the motorcycle. That's my salvage value. So S, my salvage value, is equal to 16,000. Right, minus, now it says it goes down by 2,400 each year. So after 1 year, it would be 16,000 minus 2,400. 2 years, you subtract 2,400 twice, and so on. So it's not too difficult to see where this formula comes from. So 2,400 times 3, I'm still going to grab the calculator, so 16,000 minus 2,400 times 3 equals 8,800. There we go. After 3 years, barely half the original value. So, Part B, when to the nearest month, will it be worth half its purchase price? Well, what this means is my V0 still equals 16,000. Right. I know that D is still equal to 2,400. I am going to say that S, half its purchase price, S is equal to 8,000. And N is my unknown. So, 8,000 is equal to 16,000 right, minus 2,400 by N. So, we're going to do a little bit of algebra here. You know what I'm going to do is actually add 2,400 N to both sides. I get 2,400 N plus 8,000 equals 16,000. You might not always show this much working, but I just want to do it once at least, so you can follow what's going on. So we've added this to both sides. The 2400n, right? That cancels the negative 2400n on the right hand side off. That's gone, and it puts 1 on the other side. Now I'm going to subtract 8000 from both sides, and I get 2400n equals 16,000 minus 8,000. Remember, you don't have to show this every time. Equals 8,000. Now I divide both sides by 2,400. Okay, and I'm ready now to get my answer. 8,000 divided by 2,400 equals 3 1/3, right? 3.3 recurring years. Now it says to the nearest month, so that's 3 1/3 years is 3 years 4 months. If we didn't have something so neat as the 0.3 recurring, what I would suggest you do, subtract the 3, right, for the years, and then I just know I've got that part of a year left. Multiply that by 12 for the 12 months in a year, and that will tell you how many months as well. Okay, particularly if it's not a nice, neat number like 4, if it's part of a month, right, it'll be a lot easier to round if you do it that way. Okay, next part, after how many months to the nearest month, will it have a $0 salvage value? Well, I'm going to say 0 equals 16,000 minus 2,400 n, right, similar to what we did last time. Now, this is the shortcut. I'm going to say 2,400 n equals 16,000. Therefore, n is 16,000 on 2,400. N equals 16,000 divided by 2,400. Right, I get 6.6 recurring. Right, let's use that thing that I mentioned before. Take the whole number part away, so it's 6 years. Right, we've taken care of that. Now it's that many months, or that much of a year left. Multiply it by 12 to get how many months it is, and we see that it's 6 years and 8 months. Rightio, that is straight line depreciation and the end of this topic. If you have any questions, and I hope you do, please jot them down so they're at hand and you don't forget them, so you can ask me in class. Thanks guys, see you then.